The dash by the river was steep. You just filled in that blank instantly. By bank, maybe cliff. A brand new AI model, it might guess approved or Tuesday. Every word is equally likely because it's never seen a single sentence before. Every model starts knowing absolutely nothing. It has to learn that bank makes sense here. And the way it learns is surprisingly simple. It just guesses wrong over and over. Each wrong guess make it slightly less wrong until it gets it right. Let me show you how that happens in real time.
Keep houseofthings.com open in another tab. You will want to play with this as we go along. Please find the link in description.
This is a tiny AI model, same architecture as ChatGPT, just way smaller. Small enough that we can train it in 10 seconds instead of 6 months. Right now, it hasn't seen a single word of training data. Every number inside it is random noise. Here's the sentence: the blank by the river was steep. We have hidden the second word. Let's ask it to guess what goes there. It guessed bean, not even close. This formula measures how wrong the guess was. It's asking what probability did the model give to the correct word bank. It gave it 0.03, almost zero. When you take negative log of a tiny number, you get a big number, 4.70. That's the loss model's wrongness score. The higher the number, the worse the guess. Here's what actually is inside the model. Remember from the last video, each token's embedding gets multiplied by 3 weight matrices to produce query, key, and value vectors. Look at these W matrices. These are the actual numbers, 8 by 8 grids of weights. Right now, they are pure random noise. No patterns, no structure. The model has no idea what to do with any of this. And here's the attention pattern. How much each word pays attention to every other word. Every cell is roughly the same. The model is paying attention to everything equally, which means it's paying attention to nothing useful. It doesn't know that river matters more than was for guessing the hidden word. It has no clue. Now, let's see how we can teach it something. Training works like flashcards at massive scale. Each round shows the model sentences with hidden words. Let it guess, measure how wrong it was, then nudge every weight in the model by a tiny amount to make it slightly less wrong. Repeat that 100 of times. We have got 200 steps queued up. Let's go. Watch these 5 sections update live as the model trains. Section 1, the input. Every step, we grab 8 random sentences from the small data set that and hide 15% of the words. These mask tokens are the blanks the model was to fill. Section 2, the output. For each hidden word, the model makes a guess. Green means correct, red means wrong. At the start, almost everything is right. Section 3 is the loss. This is the average wrongness across all the masked words in the batch. Very high, the model is basically guessing randomly. Section 4, this is where learning actually happens. Remember those random W matrices from step 1? After each wrong pass, the model calculates which direction each number would move to be slightly less wrong. Then it nudges every weight by a tiny amount. Section 5 is the big picture. On the right, the loss curve. Watch it drop. Each batch of sentence makes the model slightly less wrong. The curve is heading down, which means the model is learning. On the left, the attention grid. At the start, it was all roughly the same, random noise. And this is what has happened after training. Now, when we are done with 200 steps, the loss, which started somewhere near 5, is now around 2.9. Not ideal, but still, you get the point. The model figured out which words matter to which. All of that happened in few seconds. Real training for models like GPT-4 or Claude takes months and costs millions of dollars. It will take into account different types of data that is dealing with code, language, generation, images. Now, let's see how much it has learned. It's asked the exact same question, same sentence, same blank, but after training, it guesses bank. The QKV multiplication is in front of you, now showing learned weights. Look at the weight matrices, same position in the model, but compare those to the random noise we saw in step 1. These numbers have a structure now, patterns. That structure is the knowledge. It was shaped by hundreds of wrong guesses, each one nudging these numbers in the right direction. And this is the attention pattern. That's how AI learns language. Billions of wrong guesses, each one making the model slightly better. The training you just watched took about 10 seconds and used a few dozen sentences. Real training takes months and uses trillions of words. GPT-4 trained on more text that than you can read in 1,000 lifetimes. But the principle is identical. Guess, measure how wrong, nudge the weights, repeat. Now, we have a model that understands language and can generate text, but understanding isn't always enough. What if you need to look something up, do math, access information that didn't exist when it was trained? That's where agents come in, and that is what the next section and the next video is about. I'm going to leave the link to the website in the bio. Use the tool for yourself.